One of the things that we would like to do with information regarding ellipses is to be able to write the equation of an ellipse that represents the orbit of a planet. Now the equation for an ellipse is this: x squared over a squared plus y squared over b squared is equal to 1, where a is the length of the semi-major axis and b is the length of the semi-minor axis. Now, we related these two quantities in our last video to the distance c, which is the distance from the center to one of the foci. Call that focus. Okay, so that was the distance from the center to the focus. And the relationship between these three was that c squared, or c rather, was equal to the square root of a squared minus b squared. Now, if we square both sides of that and rearrange it, in fact, we get this. B squared is equal to a squared minus c squared. So what this means is that if we know the semi-major axis and we know the distance from the center to the focus, we can then calculate b squared, which is important in our equation. Now, in our last video, we said that the distance from the sun to the Earth or the sun to a planet at perihelion was equal to a minus c, and we said that the distance from the sun to a planet at aphelion was equal to a plus c. So we can do a little algebra with these two as a way to figure out these distances. Now, for example, if we add these two together, we get 2 times a, which is the length of the major axis. On the other hand, if we subtract them, so let's do it this way: aphelion, which is a plus c, and perihelion, which is a minus c. If we subtract those, okay, here we have a minus a, those cancel. And then if we have c minus c, that's the same as c plus c, which is 2c. So we want to get these numbers. We're going to add the perihelion distance and the aphelion distance to get this number, and then divide by 2, which will give us the major axis, which we need for our equation. And then we're going to subtract the perihelion distance from the aphelion distance, and that's going to give us the distance from the center to the focus, which we need to calculate b squared, which we also need for our equation. Okay, so we're going to do this for the planet Mercury. For Mercury, the perihelion distance for Mercury, we're going to call it 4.6. It's going to be 4.6 times 10 to the 10th meters. And the aphelion for Mercury is, we'll call it 6.98 times 10 to the 10th meters. Okay, so we want to add these two numbers together and subtract them. Okay, so let's call this one P, and let's call this one A. So we know that 2A is going to be equal to P plus A. So that means that 2A is going to be equal to, it's calculator time. Okay, so we'll have 4.6 exp 10 plus 6.98 exp10. Okay, and that's the sum of the two of them, which is 1.158 times 10 to the 11th, and that's meters. And then we're going to divide by 2, and that means that the semi-major axis will be 5.79 times 10 to the 10th meters. Okay, so that's one answer. Now the other answer we need is going to be 2c, and just to review in case that went off the screen, 2a was p plus a, which turned out to be 1.158 times 10 to the 11th, then we divide by 2, and this was the number that we got for the semi-major axis. Now on the other hand, 2c is going to be the aphelion distance minus the perihelion distance. So we need the calculator for this. The aphelion distance is 6.98 exp10 minus the perihelion distance, which is 4.6 exp10. So we get 2c is equal to 2.38 times 10 to the 10th power. Then we divide by 2, and that gives us 1.19 times 10 to the 10th. Now, another thing that we're going to need for each of these quantities is we need to know what they are squared. So let's start with c squared, since we have that number already on our calculator. We square that, and we find out that c squared is equal to 1.4161 times 10 to the 20th power. And a squared, we're going to take 5.79 exp10 and then square that, and we get 3.35241 times 10 to the 21st power. Okay, so we now know what a squared and c squared are. So now we're going to go up here to where we have b squared equals a squared minus c squared, and we're going to write b squared equals a squared, which was 3.35241 times 10 to the 21st, minus, and we'll squeeze this in here, 1.4161 times 10 to the 20th. Okay, so we already have that first number on our calculator, so now let's just subtract the second number. So minus 1.4161 exp20, and that gives us b squared is equal to 3.2108 times 10 to the 21st, and then and that actually is what we need for our equation. So let's put all of those together. So here's where we're going to write the equation. This is the equation of the orbit of Mercury, and this is relative to the center of the ellipse, which is halfway between the perihelion and aphelion. So we get x squared over a squared, and a squared was right down here, which is, we'll call it 3.35 times 10 to the 21st power, okay, plus y squared over b squared, and we know that b squared is 3.21 times 10 to the 21st power. Okay, and this altogether is equal to 1. Now what this tells us also is that the x-axis is the major axis, and the y-axis is the minor axis. And then using this equation, we can actually calculate, if we know what the x distance is, we can calculate a corresponding y value for any point that's on that orbit.